Welcome Wildcats. Today we are going to be talking about section 1.4, our first introduction to it, and we're going to be looking at linear functions and how we're going to take the inverses of them. So this section is called inverse of functions. So obviously we need to start by getting a couple things out of the way. First of all, what is an inverse? The definition of a function is it takes an input, the function does something to it, and then it gives us an output. A function's inverse takes that exact same output, does something to it, and gives us the original input. Now, I know what you guys are thinking. I don't speak math. That's okay. Let me show you an example. Let's take, for example, f of x equals 0.5x plus 1. Linear function. So what we're going to do is we're going to take an example input. In this case, I've chosen 4. You're going to plug in 4 for x, so you've got f of 4 equals 0.5 times 4 plus 1. Well, when you take 4 times 0.5, it gives us a 2. And then 2 plus 1 gives us 3. So we have f of 4 equals 3. What this means is our input was 4, our output was 3. So now I'd like us to take a look at a second example. We have the function g of x. G of x equals 2x minus 2. If we take the output from before, 3, and plug it into the function, we're going to get 2 times 3 minus 2. Well, we know that 2 times 3 is 6, and then we can take 6 minus 2 and get 4. So, g of 3 equals 4. Our input was 3, and our output was 4. So we took the output from our original function, made that the input of this new function, and our output was the original input. So hopefully that is a physical example that you can see what the previous slide meant. These are inverse functions. One of the ways we can define inverse functions is called the composition rule. It's just a really fancy way of saying what we just discovered. Two functions are inverses of each other if their composition is equal to x. We have two ways that we generally write this. This is f of g of x. So where you would normally have the x written in the parentheses of your function notation, you write the second function. So instead of writing f of x, you replace the x with the new function. So f of g of x, like so. There is a second way to write this. It's much less common, but you will see it from time to time. This is f of g of x as well. So it's read the same way. Note that that little circle in the middle is not actually an O. It's a circle that doesn't go all the way down to the bottom. It's in the middle of everything. And it is literally just read as of. So f of g of x. Some people call this fog notation. So continuing on with this, let's take a look at an example using our previous two functions. You may remember that those functions were f of x was 0.5x plus 1, and g of x was 2x minus 2. So let's take a look at f of g of x. Again, anywhere there's an x in your f, you're going to replace that with g of x. So we have 0.5 times g of x plus 1. When we actually substitute things in, we're going to replace that g of x with what it actually equals. So 2x minus 2. So now we've got 0.5 times 2x minus 2 plus 1. And as we simplify down, we know we're going to distribute this multiplication through the parentheses first. So 0.5 times 2x is just x. Negative 2 times 0.5 is negative 1. And then we've still got the plus 1 there at the end. When we take x minus 1 plus 1, we're left with just x. So that says f of g of x equals x. We've just used the composition of functions rule to prove that 0.5x plus 1 and 2x minus 2 are inverses of each other. They're opposites. We could have gone the other way, and I'm just going to go through this one quickly, where you have g of f of x, and then you plug f of x in for all the x's in g of x. It looks like this, and then you multiply the 2 through to get this, and then you've got plus 2 minus 2 canceling out to give you x. You do not have to do both. One or the other is enough to prove that they are inverses of each other. But what if we only have one function and we want to be able to find the inverse of it? It's a simple 4-step process. So, step 1, you're going to switch f of x, or whatever you happen to have, to y. Step 2, you're going to change x and y, so you're going to flip places with them. Step 3, solve for y. That's going to use PEMDAS backwards. You might remember the order of operations. We're going to do the order of operations backwards to solve for y. Finally, replace y with f inverse of x. So f to the negative 1 is read as f inverse. And then you're done. So let's take that g of x example that we had. G of x was 2x minus 2. So our first step is going to be to change, I said f of x in the steps, but it works for any function. So if we've got g of x, that's what we're going to change to y. Then, step 2, change x and y. So just flip places with each other. Everywhere you have a y, write an x. Everywhere you have an x, write a y. Now we're going to do step 3, PEMDAS backwards. So I see some subtraction, which is the last step of PEMDAS. So we're going to do that first. Instead of minus 2, I'm going to do the opposite of subtraction, which is addition. So I'm going to add 2 to both sides. I get x plus 2 equals 2y. And then working backwards, I don't see any addition. I don't see any division. But I do see some multiplication. I've got 2 times y. We know the opposite of times 2 is divided by 2. So, x divided by 2 is 0.5x. 2 divided by 2 is 1. And then on the other side, 2y divided by 2 just leaves us with y. So we have successfully solved for y. Now our step 4 tells us to replace y with f prime of x. Or sorry, f to the negative first, or f inverse of x. But remember, our function wasn't called f, it was called g. So in this case, we're actually going to replace it with g inverse of x. So, quick recap, 4 steps. We switched g of x to y, we changed x and y, then we solved for y, and finally we replaced y with g inverse of x. So Wildcats, that's everything we need for 1.4a. Hopefully it's going to go pretty smooth for you. You do have a homework assignment for this on MyHRW. Keep in mind that this is only section A of 1.4, so you won't be able to do all the problems just yet. Good luck.